Okay, so let's get started here. Hopefully everyone's doing all right after I tried to break your brains last week with the function stuff. So this week we're going to maybe do it just a bit, maybe a bit differently than I planned. We'll see if we get through everything I had originally planned. But the main thing I want to do is revisit the functions idea this time so that you guys are definitely on solid ground with that. And then if we have to push back some of the other stuff a little bit, that's okay. But in theory, today we're going to be talking about data types. And again, we'll see sort of how far we get into this because it's a little bit flexible for the rest of the year. Okay, so here's where we are right now. We're doing data types hopefully today. And we'll do some keyboard and timing stuff next time, talking about files. We could always kind of skip or adjust these last two, depending on how far we get this semester, or push them to the beginning of next semester, because I don't have a ton of faith that we're actually going to get MATLAB installed on all these computers in time next semester. So I think we're still basically on track here. In terms of administrative stuff, so hopefully many emails later and many deadlines, personal deadlines missed. Hopefully you guys all got your problem set feedback. Everyone get that? Hopefully you got your own problem set feedback and not someone else's. I tried really hard to make sure I didn't mix those up. So those have been marked. Comments have been sent back. Overall, I think you guys did really well on those. Like I said, if you don't start doing a little bit worse, then I'm going to have to make things harder to curve the marks down so that not everyone gets an A++. But I think probably it will be okay as far as that goes. Problem set 3 is out. Hopefully, I don't know if you guys have looked at it yet, if you guys are completely terrified by it. My plan is for it to be due Monday, so you've got 6 more days at this point. If everyone feels like that's not enough time, we can always push it back. But I think it should be enough time, especially after what we talk about today. I think it took me like 10 minutes to do it once I once I had made it, because I did actually have to do it myself to make sure I had given you everything you need to do. Of course, you guys don't know enough to do it in 10 minutes, but hopefully after today you will know enough to make it significantly easier for you to do. So, and again, I don't think it's any one really difficult problem. Once you understand all the concepts you need to understand, it's a bunch of little pretty easy problems, I think. But you may have to spend a little bit of time making sure you really understand the basic concepts so that the actual doing of the problem set becomes easier. And like I say in the problem set, if you have issues with one part, maybe look ahead and try some other parts and see if that kind of helps you figure stuff out. Okay, so we just did some notes on problem set 3, but let's just I wanted to just quickly go over a few things from the first 2 problem sets. So let's see. So I don't know if everyone's checked out the answer key. Did everyone take a look at that so far on the Google Drive? Something funny? Okay. So I'm just trying to see if there's any major stuff that's worth talking about. Okay, so I think people mostly did this one pretty well. It was about alphabetization and just being systematic in general. So some people said better to use the same number of digits, and that's true too, but mostly because you want everything to sort of show up nicely and alphabetize. People mostly had good answers for this one. And the reason I'm asking you guys stuff like this, as you can probably guess, is not because we're necessarily going to program anything that uses this, but I want to get you guys, thinking, exercising your critical thinking skills about why you do things the way you do, why you design a system a certain way, because all this stuff is, really tightly tied into programming, right? So even though a date format, that you use in human affairs is not a programming thing per se, it is an algorithm of sorts, right? So it is a system that is designed a certain way for a certain reason, and I want you guys to be thinking about that kind of stuff. Okay, I think everybody got this, although, again, a lot of the time I gave people partial credit for getting part of the idea, but not really giving the sort of deeper answer. So hopefully by example, this will give you guys an idea of the sorts of answers that I'm really looking for. So, this is a sufficient answer for this. I think, again, people got partial credit if they just said there's a typo or something like that. But it would be nice to give something a little bit more about why a typo is a problem, right? Because you as a human can see that print should be print, but you should need to say something about how the Python interpreter doesn't understand, the typo or something like that, or it produces a syntax error. So anyway, if you didn't get full points on any of these, I suggest you just take a look at the, sort of the official answers. Like this was another one that a lot of people, got some credit on because it sounded like you sort of understood, but based on what you wrote, I couldn't fully prove to myself that I definitely knew that you understood. You know what I mean? So, it's good to like sort of fully explain things as much as possible. It doesn't mean you have to write a book, but like 2 or 3 sentences that are, comprehensive should do it. I'm trying to think if there is anything. Surprisingly few people caught this one, actually. So the issue that I was looking for, a lot of people, again, said something partly right, but, a lot of people didn't say it exactly like this, that it should go 1 through 10 instead of 0 through 9. Okay, so that's just, of course, you didn't have to write this, but this is one example of explaining something you didn't understand. All right, so yeah, basically, what I'm looking for in these answers, and it's a little bit less true in problem set 3, because problem set 3 is more about like writing actual code and stuff like that. But if I asked you to explain something, basically what I want you to do is give me enough information that I can know to what extent you actually understand the concept. In problem set 2, there are a couple things that I wanted to go over. People mostly did well with the coding stuff. Hopefully it wasn't too difficult for you. I made like really picky comments, like so that you guys could have good feedback for this first problem set with real code. It took me like forever, so I probably won't be able to give you that level of feedback in the future. But of course, I'm always willing to talk over stuff if you're not sure why you get a certain number of points or something like that. So everybody's getting good at copying code, so I won't be doing that again, probably. I think everyone's got it. Oh yeah, so this is another case where like people mostly got partial credit because you said something that indicated that you knew one of the loops was running 3 times, but you didn't say exactly why the print statement in question belonged to the loop that ran 3 times and not the loop that ran 30 times. So that was a partial credit situation. And this is the one I really want to talk about because I know you all thought you were very clever for coming up with ways to do this without adding a for loop. But nobody got full credit for this because the whole point was to write another for loop, right? Because actually, even the original code was really stupid code, actually. If you look back here, there's no reason if you want to print the numbers. Well, I guess in theory you might want to, if you wanted to for some reason print out that you had every 10 numbers printed out as a set, you would have to do it this way. But it's really a pretty dumb example anyway. So the whole reason the example was there was to make sure you understood nested loops and how those worked. So the idea of the question was to try to get you to write a third nested loop, another outer loop for hundreds, so you had hundreds, tens, and ones, not just to see if you could get the output. So anyway, I appreciated your attempt at being clever and getting around it, but that wasn't the point. And so in general, if I hint that you should do something a certain way, it's because I want you to do it that way for like educational purposes. And again, it's like tenths of a point we're talking about here. So hopefully no one should feel too bad about not getting full credit on that. But if you really think I made an actual error, let me know because I might have. If it holds you back from doing the problem set. But if it's just something where you think that you might have a better way than the way I suggest, I mean, it is possible, but I probably asked it for a certain way. So mostly you should try to take the hints that you're given because I want you to like make sure you understand things like how to do nested loops, with 2 or 3 or 4 or however many loops you want. Okay, got pretty good answers for the range and X range question. We're going to see more on lists today, so we won't bother too much more with that. Let's see. This one, people mostly did pretty well with the code stuff, so that's good. People did well there. There was an error or two that people got credit for. People did pretty well with the Donald Knuth reward checks. A lot of people had other than strip 816, but again, it was only a tenth of a point, so don't feel too bad about that one. A lot of people figured out the PDF thing pretty well. A lot of other people had good guesses, so that's all good. Okay, So I'm trying to think if there were a couple other issues I think I was going to bring up, but we don't need to get too deep into it for the sake of time. So did anybody else have any questions or issues or things in problem sets that are worth discussing? Okay. Anybody got any questions about problem set 3 yet? Again, there's a lot of information here, a lot of files to download and stuff, but I think I'm trying not to give anything away today. But I think probably you will be pretty well equipped to do this after today, especially. Okay. All right, so everybody ready to go onward and upward? Oh, and last thing, as noted down here in my notes section, if you are, like again, everyone's doing very well so far, I think. If you do find that you're struggling or whatever, or think that you don't have enough time or whatever, just let me know, because if it's just one or two of you, I'm happy to kind of work with you a little bit more to make sure you understand something. If everyone is like totally lost, then of course that means the whole class needs to slow down a bit. So just let me know, because I don't know exactly how fast I can push this stuff out to you guys. So, and cram it into your brains. So, you have to give me a little bit of feedback, hopefully. Okay. A little bit more of administrative stuff. I'm going to be talking at you a little bit more today than usual, so sorry about that. It's probably worth at least talking about projects a little bit at this point. Remember that projects for this class are going to be 30% of your grade for the class. Your proposal, which is 10% of that, so it's out of the 100% of the class, it's 10%, right? So it's a third of your project grade is due in December. Like it'll be like the last day of the semester, whatever that ends up being. My suggestion is that this should take you, a couple of pages. Don't freak out. This is not like a formal essay. 1,500 is on the high side. 500 is like a page or two. Well, like 2 pages, which I think is fine, because this is not like formal essay writing. This is to show that you have a plan for your project. So the point of this is not to overwork you guys with a bunch of work. My hope is that if we do a lot of little coursework over the course of the year and kind of spread it out, we're not loading everything onto the exam at the end of the year, and that you'll get better grades overall because we're sort of pacing ourselves, right? So, so this write-up this proposal doesn't have to be anything crazy fancy, okay? It just has to be basically what I want you to do is I want you to have decided by the end of this semester, and maybe start working on what your project is going to be for this whole module. Obviously, this is a project much smaller in scope than like your final year project, right? But basically, I want you to do a write-up just to tell me what you're wanting to do, so that we can decide if that's a good project, if it's a good size and everything. And I think, again, this is just my idea. I think a couple of pages is plenty. Really, like, again, 1,500 words is probably too much. 2 to maybe 3 pages is probably plenty, if you write it well. So in terms of what you might do for your project, so it's pretty open-ended actually. So anything that you could be able to do by the end of this module is fair game. Probably I would suggest that most of you implement some sort of cognitive task in PsychoPy using only code, right? So the whole point is to use your code skills, not to cheat and go back to the PsychoPy builder. So no builder usage is allowed. But anything you do in Coder is fair game. Now, it could be something like data analysis or something like that also, but we're not going to really get into that too much until next semester with MATLAB. So I'm assuming, just due to the fact of what you've learned already, that most of you are probably going to want to do more something along the lines of cognitive task, and more something like more something in Python and PsychoPy, not something in MATLAB, just because you won't have learned all of it, until halfway through next semester. So, so it's probably going to be easier for you to stick with Python. But basically, what I'm hoping for you guys is, that it's a project big enough to be worth 30% of your total grade for the class. But really, anything is okay. And you'll sort of be, I think, the size of the project can sort of depend on like how much work you have to put into it to pull it off. So if you do something like, you don't have to write 500 or 1,000 lines of code. If you want to do like one simple thing that's maybe a bit tricky that takes you a while to figure out that we didn't really teach in class, or if you want to do something that's like kind of safer because it's all stuff that we did in class, then something a little more involved might be better. So we can sort of like trade it off depending on like how much you want to go outside. Like if you go outside what we've talked about in class a little bit more and do some sort of independent research, pull in some modules that we haven't talked about or whatever, then that I think a simpler project is fine. Or if you want to again stick to the stuff we've already taught, you might want to make it a little bit more complicated. But anyway, so if you want to talk to me about your potential project beforehand, that's fine. We can talk about that before class or in my office or whatever. One good idea we had talking about final year projects was that if you're doing a final year project that's a cognitive task and you're going to use ePrime or PsychoPy Builder or something like that, depending on the task, I think one perfectly good project proposal that a lot of you might want to do is just to implement your exact same task as in your final year project, but do it all via code in PsychoPy, instead of doing it with ePrime or PsychoPy Builder or something like that. And that's sort of useful because, like we said, you couldn't really just do your final year project in PsychoPy Coder and like use the same work for both because that's not quite right. But if you had a project that you were already doing in another piece of software, I think adapting it or translating it to PsychoPy code would be totally valid. And you can add or remove features depending on how difficult they are to implement. So if you're doing something really crazy in ePrime, you might want to simplify it a bit for this, or if it's almost too easy, you might want to add some features like writing out text files or analyzing your data or something like that. So anyway, just wanted to give you a quick briefing about sort of what you want to be thinking about for your projects. I'm totally open to suggestions. I don't think it should be anything too difficult, but it should be something that like definitely proves that you've learned something that you could use the skills that you've learned in this class to do something kind of useful like a cognitive task. Oh, and it's worth mentioning, group projects are also okay. Like if people want to get together to do something more complicated, that's cool as long as like each of you is doing kind of some independent piece of it. Because I want to, you still need to be graded separately. So if you wanted to do some really crazy complicated task or something like that and have like 3 people each work on different parts of it, that's cool too. It's just up to you guys. Okay. So basically the proposal should just be a couple of pages like, so if you're doing, something like a cognitive task, you might say, all right, well, the task I propose is going to be like this. You write it sort of like you would a methods section in one of your practical lab reports. You'd say, all right, we're going to have this many trials, and this is what might happen on the different trials. And, the modules I'll need to use will be, the PsychoPy visual module, and I'll need to be able to draw circles or lines or whatever in certain places. Talk a little bit about the stuff that you've already learned that you can pull in, and maybe what stuff you will have to like teach yourself about in order to pull it off, things like that. So again, I think a couple of pages is plenty, but you should kind of give enough detail that I can sort of tell, that I could replicate it myself if I wanted to. So just kind of like a method section basically. And feel free to include some pseudocode if that is helpful to you. You don't have to. It can be all just text. But anyway, that's just to sort of remind you to be thinking about this. You've still got like a month and a half, so it shouldn't take too long to do these proposals. And I think we've got it built in so that like the last problem set will be due like a week before the proposals due, if I've got that right. So you'll have like some time that you're not burdened down with problem sets. So anyway, if all this seems like too much, let me know. We can like lighten it up. But I don't think this should take a ton of time. I think you mostly just need to come up with a good project, and then it shouldn't take very long to actually produce a couple pages describing it. Okay. Any other stuff, questions, things people are having issues with? Any of that? Okay, cool. All right, so let's talk about our old friend functions from last week. I realize this is where I think the wheels came off a little bit, so we're going to go over this again a little bit slower this week. It's going to be a bit different. This time, I think mostly we're going to be doing some demos soon. This time, I think, unless you totally get it, what I would suggest is don't bother typing in the code along with me when we do the demos this time, because I can just give that to you later. The main thing is that I want you guys to really like pay attention and understand. So pay close attention. I think this will make sense after we go over it this time. I've slowed it down a little bit, and I think we'll all be good here. So, all right, so talking about functions, the thing to keep in mind that I think was confusing people the most is that information when you're programming in Python can go by different names. So before we get into like actual programming, just sort of think about this conceptually. Like if you have the data 7, right, the number 7 is the information, you could call that something like number of deadly sins, number of wonders of the world, number of Horcruxes that Voldemort has, and you could call it Dave, right? It doesn't have to be an informative name. The idea here is that when you're creating variables, to represent a piece of information, you could come up with any variable name in the world to represent that information, right? But the key thing is that the same information can also go by different names in different places, and I think that's what was confusing people. So what that means for functions is that you have to keep in mind that a function is basically like, it's different than what we've done before where it's just a list of commands that kind of run in order. A function is like a freestanding bit of code that can be plugged into other code wherever you want. So again, a good way to think of this function idea is like a factory machine. So you put some stuff in, you get some stuff out, but the machine itself doesn't really understand what it's a part of. So if you've got this big assembly line process with hundreds of machines that each put together different parts of a product, each machine only does its one job, right? So it takes what it's given, it does something to it, it spits out something else, but it doesn't know that it's building a car or whatever. It only knows that it's building tires, right? Or whatever you want to say. So that's the basic idea, is that this function is kind of a freestanding bit of code. It knows what you've put into it, it knows what it wants to spit out, but it doesn't know why you're doing that, right? It just knows that it should do its job when you use it. So that means that when you give information to a function from outside, it uses its own private names for that information, or what we would call a local name. So what that again, like, so if you put some raw materials, some ore or some, I don't know, rubber or whatever you're making with this machine, you put that into the machine. It doesn't necessarily know what it's called outside the machine, so it has its own name for stuff. And this will make a little bit more sense in just one second. But the basic idea is that each script that you run or each function that you build can only talk about the variables that are defined within that one piece of code. The word for this, I didn't put it in here, but the word for this is scope. So that means the names within a function have a scope, and that scope is only within that function, meaning that name does not have a meaning outside of that function. And this makes sense, right? Because like if you think about this, when you're coding up your task and you call some variable like my data, or you call it like X or something like that, you are obviously not the only person in the world to ever have used the variable name my data or X or something like that. Obviously that name has been used elsewhere, but when you write the variable name my data or X or something like that, you don't want to have to go through all the other Python code that's installed in all the other modules on your computer and make sure no one else has ever used that name before you use it, right? So you want that name to have a meaning only for you, that's not used anywhere outside. So that's kind of the idea here. So another way of thinking this, think about it like, you can also think of a function as being like, say, your family, right? So my name is Matt, which is not a common name in this country, but a super common name especially for white American males born around 1980. Like back at Yale, there were, like when I went up to the floor where one of my good friends worked, whose name was also Matt, there were like 4 other Matts that all worked on that same floor. And sometimes we'd all be standing around in a circle and it'd be like 5 guys named Matt all talking to each other, right? So out in public, of course, if somebody says Matt, all of us turn our heads and look, around, right? So you have to use, our full names or whatever. But within our families, of course, or within a small group of people, if you're the only Matt around, somebody can just call you Matt, and that's fine, right? You don't have to worry about, someone 2 miles away calling their friend Matt, because everything is private, right? So like in a private circumstance, you can just use, the name Matt, and that's fine. You don't have to worry about the usage of the same name, right? Now, if you have information you want to share with the outside, you have to worry about what we call global variables that everyone can refer to, but that's well beyond the scope of this course. The whole point is that, within your function, you know that the names are unique because you can only use the names that are defined within that function. And again, I know that's still probably a little confusing, but I think it'll make more sense soon. And anyway, what we say is that each script or function has what's called its own namespace. So there's some set of names that you have defined in that function, and those are the only names you can use within that function. You can't refer to some other variable in some other function. Okay? So the basic reason this is useful is because obviously you don't want to pass the exact same information to a function every time you use it. You want to be able to pass in different information of the same general sort and then have the function do its thing on different types of information that you give it. So the analogy that I'm making here is think about a factory machine now that's a painting machine. So you send a part in on like a conveyor belt and it paints it, right? And this is a painting machine. It knows that it paints. It knows that it needs two types of input, a thing to paint and some paint, right, to hold in its like paint tank. So the requirement of this thing is that you send a part down the conveyor belt and you fill up the tank with paint, but it doesn't know or care exactly what the part is or what color the paint is. It just knows that whatever you send down that conveyor belt gets paint sprayed onto it, and then it returns a painted part back to you, right? So, you may be calling this part a car bumper in the color red, but the function doesn't care that it's a car bumper and the paint is red. The function just says like, this is the part, this is the paint. Paint goes on the part. That's all I need to worry about. And what exact information you send into me, is up to you. Does that kind of make sense to people? So the basic idea is that I might, outside this function, I might have some grand idea about building a car, and that, I'll send in a naked bumper, and I'm like, all right, well, first I need to get a bumper painted, and and then I'll put that on the car. But all the function knows is part and some paint, and it doesn't need to know what the grand scheme is. Okay? Is that kind of making sense to people? So we'll do one more analogy, and then we'll do some code that will hopefully make all these analogies make sense. I don't know, did people do Mad Libs as kids? Is this something that made its way to Malaysia? All right, maybe not. So maybe this analogy is not going to work at all. The idea here is that you get this you have this sheet of paper that's blank, or it just says like, here give me a noun, here give me a noun, here give me another noun, here give me an adjective, here give me a color, or whatever. And you don't get to see like what the story is. You're just given like a list of blanks. So you say like, this is because it's usually like kids and they love to say things like monkeys and silly and things like that. The idea is that then after you've provided the list of information that's required, then you like plug in that list into the blanks in the appropriate places and you get a silly story out of it. So functions are kind of like that in the sense that like functions tell you, all right, I'm going to need like a number and like a string, and then I'm going to do something with that number and that string. But the function doesn't need to know exactly what number or string it's going to get. It just needs to know what type of information it's getting. But if you guys haven't done Mad Libs, then this joke is going to make no sense. Then none of that makes sense. So don't worry about that analogy if you're not familiar with Mad Libs. Go play some Mad Libs, and maybe it'll make more sense. Okay. So let's do a little review of both functions and the sound stuff we did last time. As I said in the problem set, I think I figured out all the sound issues, but you guys won't have to make sound now. That's all kind of built into your problem set. So again, if you want to just watch, that's cool. So again, I'm going to mostly do this demo for your benefit, and I'll do all the coding. You're welcome to follow along if you want to, just to sort of make it make sense to you, or if you want to tweak stuff as I'm going. But like, if you're having trouble just following, just pay attention, and that might help you a bit more. Okay, so let's make a new file. I'll make a new file. I'll call this functions demo, just as a name. And let's say that this is going to be, these are going to be some really dumb, simple examples, but hopefully they will still be useful to understanding the idea of functions. So let's, I'm going to leave a couple lines for something later. Let's just say I'm going to use my family as an example here. My mom's name, somewhat appropriately for current events, is actually Sandy, spelled slightly differently. My mother is not a hurricane, but she shares the name with a hurricane. I'm going to say my dad's name is John. I'm not just saying that. And I'm going to define some other variable. My brother's name is Mark. Oops. Spelled it like Mark Archer because I'm used to typing his name. And my name, of course, is Matt. Oops. And thankfully for me, I think there's no baby in the family. But let's say there was a baby in the family too. You can just call that baby for now, because that baby is, unless my brother and his wife haven't been telling me something, there's no baby yet. So that's all well and good. So this is just defining some names, right? Some strings. This is just some information that I might want to represent my program for some reason. And hopefully my parents never see this podcast, because I'm going to give away their ages now. So my mom's age, she just turned 60. Age of my dad, whoops. Whoa, Freudian slips all over the place today. 59. She likes the younger man. The age of my brother is 28. And the age of me is a youthful 26. That's not true, but we're going to say it is. And let's say the age of the baby, if we had one, is 1. And you see I kind of did some weird things lining this up. I like everything to line up because I'm anal about things lining up nice like that, but it does make things easier to read when you have a bunch of data defined this way. Obviously, it doesn't really matter how you have your spaces, but it is sort of nice to see things line up when you have sort of similarly, structured statements. Okay, so let's say I want to do something like for each of these people, I want to print out their name and the age. So I could go through and I could say something like print the age of, and we haven't really talked about this little business. We've done this in a couple of our demos before, but we haven't really talked about what this means. We'll talk about it a little bit more today if we have time. Although some of you guys have probably figured this out. So let's do this in order, I guess. So let's do age of mom. Or sorry, actually, the first thing I want to put in is my mom's name. So again, like I said, if we have time today, we're going to get into more of like what this function actually is, this format function. But what you can probably tell is that the 0 and the 1 here in these curly brackets or braces are placeholders, and that we're basically sticking in my mom's name and her age in the place of those placeholders, so that if I save this and run it, what I get is the age of Sandy is 60 years, right? So I could just copy and paste this code a bunch of times and just change my mom to my dad. Whoa. I don't know why I think my dad is data. I think it's just because I type data a lot. And who's next? My brother. And what do I call it? Age of bro, just to be shorter. Okay, so if I can run that, I've got all this, and that's all true. That's fine. But you might say like, all right, well, this is clearly, I'm using the same statement essentially, and just plugging in different data. So in some ways, it might be nice, if I'm going to be doing this a lot, to have some sort of general purpose function that prints the age of a person. And in this case, like each of these print statements is only one line of code, which is it's one line of code, so there can't be any less than one line of code. But even so, it might be nice to kind of condense this statement into a function that better expresses what I'm trying to do. So, it adds to the abstraction if maybe I want to create a function that that does age printing for me and replace all these statements with that. So what I'm going to do, and this is, I think, where some minds got blown last time, so I'm going to slow this down a little bit. For our purposes, it is actually the case that you can define functions in lots of places, but for our purposes, let's just say that in this class, we're pretty much always going to define all of our functions in a separate file that we then import like we do a CyclePy module, okay? So what I'm going to do is I'm going to create a new Python file, and let's just call it like, sumfunctions.py or something like that. Obviously, if you're writing a program, that's like a certain task or something, you might want to give it a slightly more informative name. But for right now, we'll just call it sumfunctions.py. And back in the functions demo, what we're going to want to do to make sure that we can use the functions that we define in there is we're going to use this magical statement from sumfunctions import star. Okay? And what this means is when it sees this statement, it looks for a file called sumfunctions. It adds the .py automatically because it knows it's looking for a Python file. Import means I want access to everything that's defined inside this sumfunctions file. So any functions defined in sumfunctions.py, I'm able to use as if they are functions inside this file, okay? So what this basically does is it lets us keep our code kind of separate. Like all the definitions of all these functions we can kind of hide away in this file, and then once we've got them all set up the way we want, then we can just use them in this file. So basically, again, the reason we do this is what we call abstraction, right? So when we're writing our main script here in functionsdemo.py, we want to mostly concern ourselves with like conceptually what we're doing. We don't always want to worry about all the little details once we've gotten a lot of them figured out. So we're going to want to bury a lot of the details in these function definitions in this file and just import that file so that we can use it in our main script. Okay? Hopefully this will kind of make sense when we actually define a function. So let's do that now. So let's define a function called print name and age. Okay? Of course, we could call it whatever we want, but helps to give it a name that says what it does. So we use the def keyword to define a new function. And print name and age is going to need some information to print out a name and an age. Obviously, you need to give it a name and an age. So again, we're not going to be too creative here. We'll just call the variables some name and some age. And make sure to include that colon there, because that's important. And we then can write some code in here. So what we've basically done here in this function definition so far is we've created two variables called some name and some age. And instead of setting those variables equal to something, instead of us saying like some name equals Bob and some age equals 50, we're saying basically these variables, when this code runs, these variables will take on the value of whatever is sent into this function, right? So whatever code calls this function or asks for this function to be run is going to provide the values of these variables called some name and some age. Does that make sense? So now we have these names, some name and some age, that hopefully refer to a person's name and a person's age. So we can use these just like we use any variables in our code. So we could then say we could define a variable called string to print equals, and we'll do this placeholder thing yet that we haven't yet totally explained. Do this dot format with some name and some age. I'm doing the sentence a little bit differently than I did it before, but it's the same idea as what we did in the previous code. And then print string to print. Okay, so this is a very simple function. All it does is constructs a string that we want to print, which is this string, so-and-so is some number of years old, and then prints it out. And actually, I could have done this in just one statement like I did in the previous function, but I want to kind of spell every step out just so it's clear. Okay? So I defined a string, and then I said to print that string. But of course, this code is not going to run until we actually use the function, right? So you can actually, if you wanted to for some reason, you could quote-unquote like run this function, and nothing happens because we haven't actually put any code in here and said to run it. We've only defined this function. So this is like building a factory machine and not turning it on, okay? All this code here does is build the machine. To actually turn it on and make it do something, we need to actually use that function in some other code. So we can go back to our main script where we defined all my family's names and ages, and we can say, we can now use this print name and age function and say something like print name and age. And now, what is it expecting? We said it's expecting a name and an age. And what we know is that, that name should be a string and that age should be a number. So we're going to give it my mom and the age of my mom. And let's just go ahead and do this for everyone else too. So let's say that's dad, brother, me, and baby. So my dad, age of dad. What did I call me? My brother, age of bro. And what did I call me? My name, age of me. And what do we call it? Some baby. Some baby, age of baby. All right. So let's run this code and see what happens when we run it now, right? So now we get this. Now we didn't take out the code to print the age of so-and-so as something years, right? So we still got those 3 lines showing up in the output. But the new things that we have showing up from these 5 function calls to print name and age is Sandy is 60 years old. John is 59 years old. Mark is 28 years old. Matt is 26 years old. Baby is 1 year or years old, right? So maybe it makes sense to you guys why this is happening, but if not, let's just, again, once more, just kind of micro step through what's happening when Python gets to this point. So, if you're sort of looking at this code, and let's say you're Python, right? So you're going through this code, you're saying, all right, my mom equals Sandy. That means I create a variable named my mom, and it represents the text Sandy, yada, 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 for the rest of the family. I'm creating some number variables now that are called age of mom. They represent 60. Age of dad represents 59, et cetera, et cetera. I'm going to do some print statements. OK. All right. It gets down to here, and it says, all right, print name and age. And it says, all right, well, I need to find, clearly this is a function. I need to find the function called print name and age. So it looks through all the files it knows about. Really, the only one right now that you're telling it to import is some function. So it says, well, hopefully, if I look in sumfunctions.py, I will find a function called print name and age. Oh, look, there it is. OK, fine. So I'm sending in 2 pieces of information. The first piece of information I send in is my mom, which is Sandy. The second piece of information I send in is age of mom, which is 60. So it goes to this function. It says, all right, function, what you call some name, I'm giving you the information Sandy to put in that blank. And for some age, I'm giving you the age 60. Does that kind of make sense? So it's like, we call it passing information. So, this script, functions demo, says, hey, print name and age. Here's 2 pieces of information. And print name and age says, all right, well, I'm going to refer to this because I don't know what you're using that for. So I'm going to refer to it by my names, some name and some age. Does that kind of make sense to people? And then it goes through and it does its thing. It creates this string to print and actually prints it out. And then when it's done, that line of code is done executing, right? So then you go to the next line of code, do the same thing, but you this time pass in the information, my dad and age of dad, and you pass in my brother and age of bro, then my name and age of me, and some baby and age of baby. And the function does the same thing each time, but you're giving it different information to work with, okay? Of course, the function, print name and age, still refers to those pieces of information with the same names, right? Some name and some age. So never in its time of executing does this function know about the variables named my mom, my dad, my brother, and so forth. It only knows that it was given 2 pieces of information. It has its own name for this information, and then it does its thing with the information it's given, okay? Does that kind of make more sense than the last time we did this? Do people get how that's going now? And there are some questions about this on the problem set, so hopefully that will make sense to you, right? So in other words, if we try to, let's say we just wanted to print out something like print my mom's name, you could say like print my mom or something like that, right? Which is a variable in the other file. If we try to run that code, we get it says name error, global name, my mom is not defined. What that means is, as far as this function knows, there is no such name as my mom, right? And you can look at it and you're like, but it's right there. But this function doesn't know about it. This function only knows about the names that are defined inside of itself, which are some name, some age, and then it uses those to make a new variable called string print and prints that, right? All right, does that kind of make sense to everybody? And again, another thing to note, I guess, is, although I haven't said this explicitly, is when this function is done executing, like any information that it created or anything like that goes away, right? So you construct this temporary string called string to print, you print it out. When this function is done executing and it goes back into this script, that string to print ceases to exist, okay? So when the function's done executing, everything it created just goes away unless it specifically gives information back to the code that called it, okay? But anything that it created in the course of it running is just gone forever, okay? So the function, again, think of the factory machine. Like you put a part in, you put some paint in, it does stuff. Anything it does inside the machine, you don't need to worry about. You only need to worry about what goes in, what comes out, right? Anything that happens inside is only temporary. The only thing you care about is what you stick in and what comes shooting out, right? All right. Any questions? This is important that you guys get this. So any questions about this so far? People okay? No one's head bleeding yet? Okay. So maybe we'll do a couple more minutes of this and then take a break. I think we're probably not going to get through, well, we're definitely not going to get through everything today, but it's fine. I'd rather have you guys understand stuff than like get through a lot of content. Okay. So we've done this. And this is all well and good, but let's say we wanted to do some other stuff, like print out some other vital statistics. So you guys are going to learn a lot about me today. So like let's say I know my weight in pounds, which as of this morning was 160. And I want to say something like, whoops, not print my weight. I can't believe I'm going to put this on the internet. In pounds is, can't make this public on YouTube or everyone will know all about my family. Format my weight pounds. I could have made some stuff up, but that would probably be worse. Okay, so if I run that code, we're not calling any functions we define here, right? We're just creating a variable called my weight pounds and printing out a statement. Now we are calling this format function, but that's built into Python, so we're not worrying about that right now. So far that just prints out my weight in pounds is 160, so nothing really new there. But let's say you guys mostly are probably, well, I guess everyone here is from countries for some reason that use kilograms rather than pounds. I don't know why. But maybe that doesn't make so much sense to you, when I say what my weight is in pounds. So if you want to really know what I weigh, you want me to express that in kilograms, right? So you can understand how this is maybe, now what I could just do is say like my weight in kilograms, kilograms is equal to my weight in pounds divided by 2.2, which is the conversion factor. But this is probably a generally useful function, right? Because if I want to go ahead and print out my brother's weight, which is more than mine, by the way, I always make fun of him for that. My dad's weight, my mom's weight, which I'm not going to do. They're free of that one. But if I wanted to do this again, you can understand how this is a generally useful function, right? That you might want to, instead of having to code in that number 2.2 every time, you might want a general function that turns pounds into kilograms, right? So this is a prime example of a case where we need a function, but this time we need a function that it doesn't just do something like our print name and age function. We need a function that actually produces something, right? So the print name and age function, it prints something, but it doesn't give any information back to the functions demo script that called it, right? So what we want now is a conversion function that takes in a weight in pounds and gives you back a weight in kilograms, right? So this is going to be our next foray into function writing. Okay, so what we'll do here is write a conversion function. So now we're going to look at what happens if you have a function that not only takes in input, but also spits out output. And it's not too hard. We're going to define a function named pounds to kilograms. And this only needs really one parameter or one input value, right? So we need a weight in pounds, right? Now you'll notice that what I did here, right, is if I want to create a new function, I just have a blank line and another def statement. And you notice that, again, just like your for loops and stuff that you've done before in the problem sets, it's the indentation that defines what statements belong to what, right? So everything that's indented relative to this def statement is part of this function. If now we have an unindented line, now we're in a totally new chunk of code, right? So now we can define a fresh function that's completely independent of the print name and age function. So it doesn't really matter what order these are printed in, because they're both completely independent definitions. Okay, so this is a pretty easy calculation to do, right? So weight in kilograms. So we're going to create a new variable called weight in kilograms, and we're just going to take the weight in pounds, weight in pounds divided by 2.2, right? And now the trick that we have to do to give this information back to the function that called pounds to kilograms is we have to use the statement called return, and we have to send it back the weight in kilograms, okay? So what this is saying is we've defined one parameter, right? So this is one piece of information we're expecting to be given, and we're going to call that weight in pounds. So that's then a variable that this function can use. It's going to create a new variable called weight in kilograms, and we're going to set that equal to whatever the weight in pounds is divided by 2.2. And then we're going to take that information and give it back to the function that called pounds, or we'll give it back to the script that called pounds to kilograms, okay? So the way we can use that is back in this script, if we want to get my weight in kilograms, we use this equal statement that we've been using all along, but now we're going to use it for a function that we've defined ourselves and say my weight in kilograms equals pounds to kilograms, my weight in pounds. Okay? So what this is saying is call the function. This is just like functions in math, if you can maths. If you think of it this way. So if you think of this as like f of x, right? If f of x is x over 2.2, when you evaluate that function, so if you take pounds to kilograms, give it my weight in pounds, that function is going to do something and return a value. So that value is going to take the place of this whole statement, right? So, if you have f of x, x is 160, f of x evaluates to whatever 160 over 2.2 is, then my weight in kilograms, this new variable, is going to be set equal to whatever value that function returns, right? Now, of course, if the function didn't return a value, we'd be in trouble. So we have to make sure that if we have a statement like this that's expecting pounds to kilograms to produce a value, we have to make sure that there is a return statement, right? So you don't need to have a return statement in a function like print name and age because it doesn't give any information back. It just does something, but it doesn't have any output or it doesn't have any. It does have output on the screen, but it doesn't have any information that it produces that it needs to give back. But if you're expecting to get back information, you need to have a return statement, okay? All right, so if we do this, now we should have a new variable called my weight in kilograms. And if we wanted to print that out, we could say my weight in kilograms is this, just to prove to ourselves that this worked. And okay, so now when we run this, we get my weight in pounds is 160. We had that before. My weight in kilograms is apparently 72.72727272. Okay? So what we've done is basically called this pounds to kilograms conversion function that has taken in a weight in pounds, done something to it. It's returned a value, which is assigned to the variable my weight kilograms, and then we can use that in like a print statement. Okay, does that kind of make sense to people? So now we've done functions that don't return any information, right? So we've done a function that takes in two pieces of information, does something but doesn't return any information. And now we've also defined a function that takes in one piece of information and returns another piece of information. All right, so that's one input parameter and one output parameter. Does that kind of make sense to people? Any questions so far? All right, so maybe we'll take a quick break. Hopefully we'll get to some cooler stuff, in the next few minutes, but it is really important that you understand this stuff because functions are really important. So this is probably about as dry as it's going to get. And then we'll actually, at the end of this class or early next class, we'll get back into like making pretty things that we can use as cognitive tasks. Okay, so let's start up again. So we've now done functions that take an input, produce output, and so forth. But I haven't told you enough about my personal information yet, so we're going to do it with some other stuff. So, like, let's say if we wanted to, print out my height as well as my weight for some reason. We could do some stuff like, whoops, well, I can't spell. So we could, do something like my height in centimeters, I'll tell you is 180. And, I could reuse some of this code kind of that I've done before, but I, change it around a little bit so I can say like my height in centimeters is something, and then that's going to be my height in cm. Right, so we could do something like that if we also wanted to print out my height. And we could even make another function, and hopefully this will be fairly obvious. So we'll just do this quickly because hopefully you guys get the point now. So if you want, you can go ahead and maybe take a second to write your own centimeters to inches conversion function. The conversion factor is 2.54 centimeters per inch. If you think you can do that. And I'll start doing it myself slowly. Maybe you've already got it typed out. So I'm going to call mine centimeters to inches. That will also need one. Let's call it something different actually. Let's call it something like centimeters. And let's see. So let's call this okay, so that's a function to convert centimeters to inches. Notice that I started, my first instinct was to call this something like height and centimeters, which I could have done because, again, the names in this function don't know anything about the names out here. But actually, it's more useful because it's not always going to be heights. It's more useful to call it something more generic like centimeters, right? Because it could be length, it could be some other kind of measurement. So, again, the whole point of functions is that I don't have to worry about the names I create in here because they're completely distinct from the set of names that is available out here. All right, so if I want to now get my height in inches, hopefully you guys know how to do that now. So what do I call the function? Call it cm 2 inches. My height centimeters. So now I should have a variable that represents my height in inches. And if I wanted to print that out, I could just change the word centimeters to inches and change the variable to my height. That's not my height in nothing. It's my height inches, IN, the abbreviation for inches. Okay, and that does work, right? So now we see, if we print that out, my height in centimeters is 180. My height in inches is 70.866 apparently, which is close enough. I'm 5'11", so that should be right. So that's good. That seems to work. So that's not doing anything really special that you haven't done before. This is just doing another example of the same kind of conversion. But you might say, well, all right, we've just done two pretty similar things, right? We just printed my height in centimeters. We printed my weight in pounds. So if you want to do that more generically, we've done a lot of things like, all right, we printed out like ages and years of different people. We printed my height in centimeters. Maybe it's easier to write one general purpose function for printing someone's measurements of some sort in general for any person and any measurement, right? So let's try something like this. And again, this is not doing anything totally new, but hopefully, you'll see like why functions are kind of useful. Again, it's sort of a dumb example, but you can see how this kind of simplifies the code a bit. So if we define a function, let's just call it like print measurements, right? And let's say we want to be able to print someone's measurements for any name, for any quantity like age or weight, for any units, kilograms, centimeters, years, whatever, and then of course the actual number, right? So what we're going to really need to define in this function are a person. I'll call this who, like the person's name. We call the measurement, so whatever we want to call it. I'm just going to call it mes for short. Whatever the measurement is, whatever the unit name is, and the actual number. And again, you can use whatever names you want. This is just the names I used. And you could construct a string, just like we could call it like, just to make a point, we could call it string to print like we did above. Again, it doesn't really matter if we use the name string to print here when we've already used it up there, because these functions don't know anything about each other, right? They don't know what variables they have inside them. So you can reuse names in different functions, right? Because each function has its own private namespace. So then what we want to do is make some really generic string like some measurement of some person in some unit is some number, right? And again, this whole notation we'll get to a little bit later today if we have time. Format. So we want to basically say the measurement, whatever it is, of the person who in the units is some number. And then we want to print out the string to print, right? All right, so that's our basic function. And so now if we wanted to reprint all this information we've already printed, with this one function we could do something like print measurements my mom. So again, we have to remember what order these are defined in, right? So what the measurement is, the units, and the number. So the person is my mom, the measurement is age, the unit is years, and the number is, what do we call it, age of mom, right? And now if we want to print out everyone else's age, we can use that same function. So we've got dad, brother, my name, and baby. So my dad, my brother, my name, and some baby, and their corresponding ages, age of dad, age of bro, age of me, and age of baby. All right, if we run that, you see what that function is going to do now. Say the age of Sandy in years is 60, the age of John in years is 59, the age of Mark in years is 28. It's a little bit of a funky phrasing, but one nice thing about this function is that it generalizes well to other measurements, right? So now if we want to use the same function to print out my weight, my height, and so forth, we can say print measurements my name, and now instead of age we'll do my weight in kilograms is weight in, what do we call it, kg. Maybe we want to print out my height in inches is weight in, height in inches, height my height in. Is that what it is? My height in. Oh, you know what? I got this. This is not going to work, right? Because I called it weight in kg, but it's actually my weight kg. So get the name right. My weight. Not in kg, just my weight kg. All right, so you can see we can use the same function print measurements now to sort of generalize to all sorts of things, right? The weight of Matt in kg is 72.72. The height of Matt in inches is 70.866. So you see, like, this is why functions are useful, right? Is you don't have to have now like all this specialized code to print out inches and pounds and kilograms and so forth. You can use the same basic function, plug in a name, which is a string, right? A type of measurement, which is a string, the units, which is a string, and some quantity, and the function, will then work for anything, right? So again, this is useful because it's abstraction, right? So it's generalizing a bunch of cases, right? Like, you want to print out heights and weights and kilograms and inches for different people and so forth, and making one sort of general purpose function that does all these things, right? So that you don't have to duplicate code, so you can reuse it very quickly, and you don't have to worry about a lot of the details, right? Okay, so that's cool. So now let's do one more kind of conversion function idea to really let this sink in and to illustrate one other idea, which I think I went over too quickly last time, which is the idea of default parameters. So let's tell you one other piece of information about me, which is the amount of cash in my wallet right now. Actually, it's not right now, but it is what it was yesterday before I went to Starbucks. Now it's a lot less. So let's say I had 234 ringgit in my wallet yesterday. I just gone to the ATM. So, if I wanted to print out like how much money I've got, I could say print measurements, my name. Let's call this like wallet contents, right? Contents. And use the code for Malaysian ringgit. And my cash in MYR. So if we wanted to see how much money I've got in my wallet, the wallet contents of Matt in MYR is 234. Again, kind of a weird way to phrase it, but if we want to generalize this function to print out anything, we might want to use some sort of generic phrasing like this. And again, that's nothing particularly new, but now if we wanted to write a conversion function, if we wanted to say how much I had in the equivalent of US dollars, we could write one of these conversion functions like define, let's call it Malaysian ringgit to US dollars. This is a function that's near and dear to my heart because I'm always transferring money back and forth between accounts. So let's call it, so let's define this function saying we're going to have an amount in Malaysian ringgit. And let's say, probably want two things, right, which is, so in order to convert the two things, we really need to know, unlike kilograms, right, it's always the same number of pounds per kilogram, right? It's always 2.2 pounds per kilogram. Now, the exchange rate between Malaysian ringgit and US dollars varies hour to hour, right? So again, if you're someone who's living in a foreign country, and you have to transfer money back and forth, like I do sometimes, because people renting my condo don't always pay rent, and I need to transfer some money from here over there so that I can continue to maintain my real estate or whatever. You want to check and you want to transfer money when the conversion rate's favorable, right? So, so this is a conversion function that really needs two parameters, right? Not only the amount, but sort of what the conversion rate is. But it's the same basic idea, right? So we could say the amount in, so if we want to calculate the amount in US dollars, that's just going to be the amount in Malaysian ringgit divided by the number of Malaysian ringgit per US dollar. And then, of course, we want to return that information, right? We want to give it back to the function that asks for it. So we return the amount in US dollars, save it. And then back here, if we want to calculate what my cash is worth, if I wanted to convert it to US dollars right now, I could say my cash in USD equals MYR to USD, and we give it my current cash in Malaysian ringgit. And at least as of yesterday or so, the conversion rate was about, let's say, 306. So about 3 ringgit and 6 sen per US dollar, roughly speaking. And so then we could say something like, we could copy this print measurements function again, but now say the value of my wallet contents in US dollars is my cash in USD, right? And that would work. Oops, doesn't work. Why doesn't it work? Who can tell me what I screwed up? Oh, I'm always doing this. No colon, right? All right, so always need that colon after you have a def. All right, so 234 ringgit, at least as of yesterday, was worth apparently 76.47 US dollars, which is more money than I would usually carry in my wallet in the US, but that's because I use credit cards everywhere. But okay, so if I wanted to go to the little conversion shop and convert, that's what I would get. But there are some other things. So this is, again, nothing too new so far, but let's say, you don't always know exactly what the exchange rate is, right? So, if you want to just sort of, take an educated guess, you might say, all right, well, we know, if you look at like Yahoo Finance or something, it hasn't changed that much over the last couple of years. It goes up or down by, 10 or 15 cents per dollar, but it's usually kind of roughly the same amount, right? So maybe we don't always want to provide the information as to how many Malaysian ringgit per US dollars there are. So what it would be nice is if we had the option. We talked about this a little bit last week. It's sort of like setting preferences in Microsoft Word. Like sometimes you want to be able to set a value for something if you want to use a specific value, and other times you want to just use a default value, right? So like when you start up Word the first time, it doesn't have to ask you every single time what your preferences are for like, whether or not to correct your grammar and what language you want to use by default and what default font you want. It has preset preferences, but you can also set them specifically if you want, right? So we want something like that. And it's very easy to do this now that we have this function defined. So if we want to say, we don't always want to have to provide the conversion rate. If we don't provide a conversion rate, just use some default value, we can do that. So all we have to do is up here in the function definition, we can just say equals, let's say over the past couple years, it's been about 310 ringgits per dollar. Let's say we'll just use the value that's been the average over the last 2 years or so, about 310 ringgit per dollar. And it's a bit of a confusing syntax, and I think this kind of blew people's minds last time. But what this is basically saying is, if we set this in the function definition, it doesn't mean that MYR per USD is always going to be 310, but if we don't tell you otherwise, basically we're saying to this function, if I don't specifically give you a value for this, just use 310, okay? So let's see how this works in principle. So if we say, in practice, not in principle. So if we say something like, now we will use the default value or conversion rate or something like that, conversion rate. So now let's recalculate my cash in US dollars. So we can keep this line. But now let's say we don't want to give you a specific conversion rate. We want to just take that out. Now this is it's a bit weird, right? Because in the function definition, we have two things defined that it's wanting, right? It wants an amount in ringgit, and it wants a conversion rate of ringgit per dollar. But we're only giving it one thing now. So what it's going to do is it's going to say, all right, the first thing I got is the amount in ringgit, and I wasn't given a second thing, but I do have a value, a default value that I can use for that. So I'm just going to use that default value now, okay? So let's see what happens if we, now let's print it out. So we'll print out the new US dollars measurement. It's going to be the same thing again, right, because we just reused the variable name. All right, so what we have here is we have what we had before, right? The wallet contents of me in ringgit is 234. The wallet contents of me in US dollars is 76.47. But if we're using the default conversion rate, now that would only be worth 75.48 whatever, right? So you guys see how this works? So basically, if we call this ringgit to dollars function and only give it the amount in ringgit, it'll use the default value of 310 ringgit per dollar. Now, we've still got this code up here, right? We still have this code up here where we said, here's the amount in ringgit and here's a conversion rate. And if we give it a conversion rate, it'll use 3.06 ringgit per dollar, and it just ignores this default value. So it kind of lets us have the best of both worlds, right? It lets us say, all right, well, if I am not given this information specifically, I have some fallback information that I can rely on, but I can use the specific value if you ask for it. And again, this is what I was trying to get at last time when we talked about PsychoPy functions. So if we go to like the PsychoPy documentation, let's do PsychoPy circle or something like that, right? Because we made circles before. If you look at the function for creating a circle in PsychoPy, it's really complicated, right? If you look at the arguments that it wants to create a circle, if this ever loads, there are a ton of arguments that you can provide when you're creating a circle. All right, this is not working. Let's try that again. Okay, I don't know why this is not working. Try it one more time, then we'll give up. It's hanging up on Facebook Connect, apparently. Let's try this. Oh, wait, no, not that one. Let's do... Where's the epidoc one? Okay. So let's look at creating a circle in PsychoPy Visual using this thing. This is annoying. All right, well, let's just do something like a shape stem or a text. Let's do a text stem. Okay, so if you're making a text stem, you could provide all of these things. Don't worry about the details here, but you could provide all these things like the text, the font, the position, the color space, the opacity of the text. So when we've made text stimuli before, right, we haven't provided all these things, right? We haven't ever had to say when we made text before, I want an opacity of 100%, right? I want it to be a totally non-transparent text because these things have default values, right? So the whole point here is that sometimes it's nice to have a lot of options, but only have to use a few of them at the time, not to have to provide all these values every single time. Does that kind of make sense to people? Sort of, maybe? Okay, so I know this is like super boring stuff, but this is, once we get through this, hopefully this will be the hardest part of anything we do. Okay, so there's a couple other things we want to maybe do. Let's also say, this is a bit tricky. Let's say we just want to know, let's say we don't want to use any parameters when we call this. Let's say we want to have a default value for the amount in ringgit also. So like in other words, maybe I don't want to give you a specific number of ringgit. I just want to know the general ringgit to dollar ratio, right? So we might say, well, if I don't provide any inputs, I just want to assume that, I want to see what 1 ringgit is worth in US dollars, okay? So we can do that too, right? So we can give default values to both of these input parameters. And then if I say, I can say, if I want to know what 1 ringgit in US dollars is worth, I can say MYR to USD, empty parentheses or empty brackets. So I'm calling the function, but I'm not actually putting anything inside the brackets. I'm not giving any information to the function. So when this MYR to USD is called, it says, all right, it didn't give me amount in ringgit or ringgit per dollar. So I'm going to assume the default value for both of those and just give that back. And so we can then say print measure, let's actually not use print measurements because it doesn't really work, but let's say Print the default value of RM1 in USD is that, and print out what RM1 in USD is. Let's see what that gives us. Okay, so it gives us the right value, right? So 1 ringgit in US dollars is worth about 32 US cents. So basically what this is doing, right, is this function's running just fine, and it's saying, all right, I'm assuming the amount in ringgit is 1 if I'm not given anything else, and assuming the default conversion rate also. So that's all well and good, right? So if you provide 2 default values, it'll just use both of them if you don't actually pass in any values here. Now the key thing is, if you don't provide a value to this function, it has to be defined somewhere, right? So let's say I took out the default value here, right? Let's say I didn't have that defined. This would no longer work, right? Because now it's saying it wants at least 1 argument, right? So in other words, if you don't give it a default value, in other words, if the function definition does not have a default value defined, and you don't give it any number here, like 1, like that would work okay, right? But if you don't give it either, it has no idea. It has no idea what to do. So basically, this default thing only works if you know that there's a default argument defined, and you're okay using the default. Then you don't have to provide that parameter. But if there's no default provided, you have to give something for that parameter. Okay? Does that make sense to people? Kind of? Everybody totally sick of this by now? So one other thing I want to show you is, so one thing to note is, if you want to provide, and this is getting a little bit deep into Python, but it has to do with how we call SciPy stuff, so it's worth noting. If you have a function that has some parameters with default values and some parameters that don't have default values, the ones without default values have to come first, okay? So this will not work. So let's say, it doesn't really matter what we use here. This will not work. So it says non-default argument follows default argument. That's something, people were getting this last time, because you can't have something like this that requires a value after something that does not require a value, right? Because whenever you call the function, you pass the arguments in, you usually pass the arguments in the order that they occur in the function, right? So basically what this is saying is, you can't give a default value that it would allow you to leave the first thing blank, but stick something in for the second thing, because that would look funny, right? That would imply that you would call it something like that, you'd have a comma without anything, which is actually valid in some programming languages, but not Python. So it's saying that it's okay to have default values that go no default value and then followed by a default value. That's okay. Oops. So it's okay to have a non-default value followed by a default value and just to pass in like 1 default value here, right? But it's not okay to have it the other way around, okay? So the reason that's interesting, and again, this is getting a little bit deep into Python, but it will be useful for when we do SciPy stuff, is, all right, so now we've returned this to the situation where we have default arguments for both, and we don't need to provide either, right? In the case where default arguments are provided, you no longer have to call, how do I say this? You no longer have to provide the arguments in the same order if you tell the function what name to use. This is very confusing. So let's do it this way. So if for some reason you wanted to say, let's do it this way. Let's say we wanted to only provide the conversion rate. Sorry, wait a minute. Yeah, we only want to provide the conversion rate and not the amount in ringgit, right? So if we want to say, let's redefine 1 ringgit in US dollars. To USD. All right, so what we ideally want to do is we really want to know what the default value of 1 ringgit is worth in US dollars, but not using the default conversion ratio of 310 ringgit per dollar. We want to know what the default amount of ringgit is worth using a specific conversion ratio. So what we can't just say, like, using yesterday's conversion rate, we can't just say this, because if we say this, that's going to tell us what 3 ringgit, oops, we have to print it to be useful, right? So what we really want it to be is the default, the value of RM1 in US dollars at 3.06 per USD is RM1 in USD. All right, so what we want to say is what the value is of 1 ringgit in US dollars, providing a conversion rate of 306 per USD. And we're not getting the right output now, right? We're getting that 1 ringgit is worth about 1 US dollar, which is not right. Because if we call it this way, we give MYR to USD one input parameter. It's going to assume that if you just give it one input parameter, it's going into the first thing. So what it's assuming in this case is that the amount in ringgit is 306, and then it's assuming the default value here for ringgit per dollar. So what we ideally want to be able to do is say, you've got default arguments for both of these things. I want you to skip the first thing, and I'm only going to give you the second. And the way that you do that is you give the name of what the parameter is. So this is one case where you actually, everything I said was kind of a lie. You have to actually know the name of this variable in this function. So you have to know that what we want to provide is what MYR per USD is. So if we say MYR per USD is equal to 3.06, that gives us the right answer. The value of 1 ringgit in USD at 306 per US dollar is 0.326. Now again, maybe you get this, or maybe you've tuned out by now, but when you get to doing the problem set and you have to write default arguments, I'll say this just for the inevitable moment when you're watching the podcast and being like, what did he say? All right, so what's happening when this code runs is we call the function MYR to USD, and we tell it MYR per USD equals 3.06. So when this function happens, it says, all right, MYR per USD is going to get set to 3.06, right? Because that's what the function that called me told me. And it never told me what the amount in ringgit was. So I'm just going to use the default of 1. Okay? Does that kind of make sense to people? It's a bit confusing, I know. But it's what it's really nice for is flexibility, right? So if we go back now to, let's pick some old version of our number guess function. So if we look at like how we've done this before, so we've been doing this all along actually with text stems and things like that. So, oh, right, so that's the one that we had trouble with last week. Let's go one further back. So let's go to CyclePy number guess 4 if you guys still remember that. So this is where we're creating these text stems, right? So this is what we've actually secretly been doing all along. When we say cyclepy.visual.textstem, we give it a window, we say text equals blah, font equals blah, bold equals true, height equals 36, wrap width equals whatever, right? That's what we've actually been doing all along, is we've been telling the text stem, so let's go look at the documentation for text stem. Let's see if this actually works. Okay, so again, it's documented a little bit funny, but just take my word for it. So the things that you can provide to a text stem creator are, ignore this self thing, that's not important right now. The window, you can provide text, which defaults to hello world. You can provide a font, which defaults to empty, which means use whatever the default font is on the system. You provide a position, provide a depth, which is like if you have a bunch of things on the screen, that tells you like what order they're in, right? Where you like arrange things, like when you arrange things on a slide. It says, you know, there's a color space, there's an opacity like we said, right? So again, when we created a text stem, we didn't define all these things, right? We only defined the text, the window, the font, the boldness, the height, and the wrap width. And we let everything else just use its defaults, right? But the other nice thing is, if you specify the arguments in this way, with like text equals, font equals, and so forth, you also don't really have to always remember what order they all go in, right? So if we had wanted to, we could have said, font equals, then text equals, then wrap width equals, then height equals, and so forth, right? So basically there's essentially what this boils down to is there are two ways to put input parameters into a function you're calling. One is to just give it a value, right? Like mycache and myr, or mycache and myr, comma 3.06. If you just give it the values, it assumes that you're sticking them in the order that they occur. If you give it a name and an equal sign and a value, it assumes that you want to replace whatever the name is with that value, okay? So two different ways of doing things, and you can mix and match them as long as you don't confuse yourself, okay? So especially this makes sense where some of the arguments are required and some are not, right? So back here, if we're creating a text stem, you can never create a text stem without giving a window, right? Because you always need to know what window to put it on. So you always know the first thing you're going to give it is going to be a window. After that, pretty much everything is optional. So you can just stick in the optional stuff in pretty much whatever order you want as long as you specify what is what. All right, does that kind of make sense to everybody? Hopefully. So basically, what we really did this whole time is explain this one line of code that we've had all along where we create something like a text stem, right? But now hopefully you guys kind of get how these arguments work. Okay, any questions about any of that? Yeah.
Can you go back to some functions?
Yes.
So you said that you have to put the default. So you have to put default arguments second.
So anything that has so any argument that has defaults has to come after all the ones that don't have defaults. So basically, yes. So you can't go like no default argument, no default argument, default. It has to be all the ones without default values and then all the ones with default values.
Okay, but take MRTU's data. So what if you set the default argument as the first one? So say amount in MRR is set to 1.
Yep.
BSD does not have default value. Could you just define MYRTUSD when you call?
Wait, say again. What?
Okay. Could you set so if amount in MYR has a default value of 1, MYR for USD doesn't have a default value, then when you call that
well, if the first thing has a default value and the second thing doesn't, that won't run it.
Okay.
That is not. It's just not considered to be valid code. Now this is a Python thing. This is not a universal programming thing. Some languages, like a lot of languages, support the idea of default values. And if we do this in MATLAB next semester, you'll see MATLAB's approach is totally different. In MATLAB, all arguments are optional. And it's up to you to know what to do in the case where there are no arguments provided. But in Python, you have to spell out which ones have default values and which ones don't. And it has to go. So like, again, this would not be valid code even if you called it in some way that made sense. It just is not allowed to have one without a default value after one that does. Yeah. Does that answer it? Okay. Any other questions? I know this is like brain melting stuff. Okay. So maybe we've got just a couple minutes left. Maybe we'll just introduce the game that I was going to play. And this is going to be me just starting to introduce this, but I just want to maybe prove to you guys that sound works because you will have to do some sound stuff on your problem set. So I'm just going to quickly, you guys don't have to type this. It's probably not even worth you typing this. But I want you to see kind of how some of this goes. Now ignore these first couple of lines. This is just some little magic I have to do. If you think what you're learning is hard, just think about all the crap that I'm hiding from you. Well, actually, we can skip this for the moment. All right, so ignore those 2 lines. Those are just magic. You don't have to worry about what we're doing. And let's say I want to have a dumb little game that we're going to play, okay? So if you guys were not alive the last time these games were popular, but back in the old days, in like the 80s, when we had computers that couldn't really do much but display text. You guys ever heard of like Zork or games like that? These are like text-based games where like you typed in commands like go north, and it would be like you go north, and there's like a dragon to slay or something like that. It's kind of like playing Dungeons and Dragons with a computer. So anyway, I'm going to illustrate you a very dumb version of a game like this just to make some points. So I'm going to write some code. This mostly should make sense to you. So the code starts out by saying, oh wait, player alive starts out true, or else the game is boring. So player alive starts out true. Call this mydumbgame.py. All right, so if the player is alive, let's say we have some game where if the player is alive, the first thing the player might encounter, so we'll say like, we use this raw input function. So we're going back to text. This is just for me, not for you guys. You encounter a dragon. Fight or flee. This is going to be a really awful game. All right, so it'll say that. It'll get an answer. And if the answer is equal to flee, then we'll print out, you ran away safely. Else, print, you died. And player live equals false. Now we don't use player alive again, but in this code, but we will shortly. So this is a really terrible game, right? Because you really only have two choices, and one of them's always right and one's always wrong. So this is not a fun game. But let's just see what happens if we play this, and you'll see in just a second why I want to do this. Yep, so what did I do wrong? Oh, anybody see what I did wrong? On line 9? Yeah, missing a colon. I always forget this because Python's, like not all languages have this feature that Python has of requiring those colons. So I'm used to MATLAB, which does not require those colons. All right, so let's see. I want to flee. Yeah, I ran away safely. I'm great at this game. If I play again, I died. Okay, so that terrible game, right? But maybe we want to make this game slightly less terrible. And instead of just saying you died, let's make some sound. So let's see how quickly I can do this, if I can type this in just a minute. So let's play a little you died tune. And if you've tried the problem set, you've seen some code kind of like this. So we're going to create a sound whose value is C, octave is 4, sex equals 0.5. Hopefully, now this syntax makes sense to you, right? Value, sex, octave are 3 parameters that are in the PsychoPy sound module when you call it. So what I'm saying is I want to a note of C. So parameters, value can be a number, string, or array. Sex is a duration. Octave, only relevant if the value is a note name. We're ignoring some of these other optional parameters like sample rate and bits and so forth. So hopefully the syntax is slowly making more sense to you. s.play and psychopy.core.weight of 0.5. This is terrible for the podcast. All right. All right. Well, this is not much of a tune, and sorry, this is going to be super loud on the podcast. But so now, oh wait, sorry, keep running it the wrong way. So I'm going to run it like this. Let's say I fight. Ah, shoot, what did I do? Oh, what did I forget? Anybody know what I forgot to do? Yeah, so I want to import. I didn't import psychopy.sound yet, right? So I forgot to do that. Let's try it again. Okay, so that's one note. That's not too interesting yet. But let's make it play. Let's copy and paste a whole bunch of notes. Let's see. So C. Let's see how quickly I can do this. Times 0.75. This is going to be pretty awesome. Oops. when it's done, and times 0.25. That's fine. E flat times 0.75. So let's see. E. So it's going to be E flat. If anybody, well, you guys failed my last test for musicians, so I don't know if. Oh shoot, I missed one. No, did that wrong. So that one needs to stay a C. So I'm not going to ask you if you can recognize what this tune is going to be, because I don't trust you guys' musical judgment anymore. E flat. Let's say a D at 0.25 seconds, or 0.25 of the 5 seconds. All right. And then a D at half of that. Let's see if we can get this out by the time we're officially over. All right. 0.5. So we'll do it. Let's just copy and paste this part. C, that amount of time. Do another one of those. Try to contain your excitement here. Almost done. A B. Oh, a B. That's one of those again. And that's a B3. And finally a regular C quarter note or half note, whatever this is. All right, let's see what happens now if I get this right in my really quick typing of that. Probably it's not right. Okay, let's try to fight the dragon. Yay! All right, you get the little funeral march, right? Okay, so terrible game, but it now has better sound than, a lot of games did in like 1978. So that's something, right? All right. So the point was here, and you guys actually have this on some of your problem set, is that what you just saw me do, I was able to make that sound pretty quickly, relatively speaking, by copying and pasting lines of code and stuff. But obviously, what you have is some very repetitive code here, right? And so, it'd be nice to be able to replace this with a function that does like a funeral march and shorten things up a bit, right? Because presumably in the full game, we're going to want to encounter lots of obstacles. Some of them kill us, some of them don't. And we don't want to have to type all this code out every single time. So on your problem set, there's a function about this. I was hoping to get a little bit deeper into it to give you some more hints on the problem set, but I think you'll still be okay without. But there are some other points I want to make with this dumb game demo. So I just wanted to introduce it for now. Next time, we will continue with this game demo. We didn't even get to the data type stuff, but I think that's okay, because better to slow down a little bit and really make this stuff clear. So that's it for now. We'll pick up with this when we resume next week. So we'll probably push everything back like a week, finish up functions and sound and data types next week, ignore whatever we were going to do, and push everything back a week or so. But I think you guys should be set for the problem set. Let me know if you have any difficulty based on what you know now. But maybe if you start it right away before you forget everything we talked about today, it'll seem pretty easy now. Okay, so any questions before we officially finish? Okay, cool.